Hello, fourth grade teachers. Today I want to model for you how to use some manipulatives in solving a problem that stems from our IOA 2D. We are going to be solving authentic division problems involving up to 4-digit dividends and a 1-digit divisor. So let's take a look at this problem. It reads, 7 athletes equally donated time to clean out their locker rooms. They spend 1,624 hours cleaning. How much time did each athlete spend cleaning their locker? Now, teachers, I know we all know what the word athlete means, and we all know what a locker room is, but I would definitely make sure that I was explaining what an athlete was and what a locker room was for them to understand that that locker room is probably pretty stinky. So making sure that the students understand the problem in context is super important. So mathematicians, I would want to know how much time did each athlete spend cleaning their locker rooms? So that is the main question that I have to answer. I know that there were a total of 1,624 hours that were spent cleaning that locker room. That's pretty stinky. I do know that there were 7 athletes or 7 people that equally donated time to clean out those rooms. So when I'm thinking about this, I'm thinking about a total amount of 1,624 hours split into 7 equal people, taking those hours and making them into equal parts. So when I think about that, I'm thinking that my equation is going to need to read 1,624 divided by 7, because we're taking those total hours and dividing it up amongst the 7 athletes to find out how much time each athlete spent cleaning the locker rooms. So this is my result, right? I have to figure this amount. But what I'm going to do is I think I'm going to represent how much that time is with the lowercase t. T is going to be the time that each athlete spent cleaning the locker room. So I'm going to have to use some division to help me solve this. To save time, I went ahead and I built my place value chart to help me with my thinking. I'm going to use the new place value discs for me to represent our dividend of 1,624. Okay, so I'm going to need to use 1,000, 600s, 100, 200, 300, 400, 500, 600. Okay, 1,620 and 24. 4 more. And so 1,620, 1, 2, 3, 4. So now let me think. I have to take this total amount, 1,624, and equally give time to 7 different players. So what I'm going to do is I'm going to go ahead and draw myself 7 circles. These 7 circles are going to represent my athletes. 1, 2, 3, 4, 5. Take this over here. 6 and 7. So here are my 7 athletes. I'm going to take this amount, 1,624, and distribute it into these 7 athletes to figure out each of their times. So, lots of different ways that I can think mathematically. But and thinking about facts that I already know. So I'm going to take some notes over here to the side. It's important, teachers, to have students write down things, to write down their thinking, not only to help you, but to help their brains as well. So I like to write facts I know, just to help with my thinking. Okay? Now, most kids struggle with thinking about how to divide numbers. So I always tell them, let's think about the multiplication facts that you do know. I do know, because we have 7 athletes, I do know that 7 times 1 equals 7. So I could start there and putting ones into each circle, but that's not really efficient. Plus, I'm already going to have to do some regrouping because I only have 4 right here. Let's think about other things I know. I know that 7 times 2, or 7 doubled, is 14. Okay. That's useful information. I could take 14, so I could decompose that 10 into 10 ones, and I could take all the ones and distribute. But I wonder if there's something else I could do. What if I did 7 times 10? I know that 7 times 10 is 70, okay? But I'm still working with a pretty big number. I know that 7 times 2 is 14, so I do know that 7 times 20 is 140. Okay, we're getting closer. This is 1,624. What if I did 7 times 100? I could get 700. We're getting a little closer to that 1,624. But what if I did 7 times 200? That's 7 times 20, which is 140, 10 times greater. So it's really 1,400. Now, thinking about that 1,400, we're getting pretty close to that 1,624. I wonder if I were just to think about 7 times 3. I know that 7 times 2 is 14. If I add one more set of 7, I would get 21. Now, thinking and reasoning through this, if I were to take 7 times 300, it would be 2,100. So that's a little too large. So I think I'm going to start off here with my 7 times 200. So I'm going to take 7 times 200 to make 1,400. So I'm going to have to use my place value discs. Each 7 is representing my circles. So each circle is going to need to get 200. So let's start that off. 100, 200, 100, 200, 100, 200. Uh-oh. I don't have any more hundreds. I'm going to have to decompose my 1,000 into 10 100s. Let me get those out. There's 6, 7, 8, 9, and 10. So I have just decomposed this 1,000 into 10 100s. So I'm going to put it over to the side. So let me continue. This one has 200, 200, 200. So let's continue placing 200 into each one. 1, 2, 3, 4, 5, 6, 7. Okay, 7 times 200 is 1,400. So I still have some left over, don't I? Okay, so let's think again. I can't do another 200. Let's go back to my facts. I know the 7 times 100 is 700. I don't have 700. 7 times 20 in each is 140. I have 224 left over. So I could do a set of 20 into each one. Okay, let me start doing that. So I have 20 right here, so I can put those in there. Uh-oh, I'm all out of tens again. But I do know that I can decompose this 100 into 10 tens. Put out 10 tens. Okay, so I'm going to take this 100 and remove it from my chart because now I've decomposed that 100 into 10 tens. Now I have some more tens that I can make sure I put in 20 into each circle or for each athlete. 20. Okay. Uh-oh, he needs some more. I'm going to decompose this 100 into 10 tens. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 takes the place of this 100's value. Okay, now I can put in 20 more into this final guy. All right, so let's take a look. I'm now left with 10, 20, 30, 40, 50, 60, 70, 80, 84. You know what? I know that 7 times 10 is 70. So I can use 7 of these to add another set. 1, 2, 3, 4, 5, 6, 7. So far, each athlete has spent 230 hours cleaning the locker room. So I have left over 14. 14 hours I need to equally distribute with these 7 athletes. Going back again to the facts that I know, 7 times 2 is 14. So when I look, I know I only have 4. I know that I can decompose that 10 into 10 ones. Now I'm going to keep these separate from these 4 so that I can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I've decomposed this 10 into these 2 lines of place value. So now I have a total of 14 ones, and I know that 7 times 2 is 14. So 7 represents each one of my athletes. I'm going to put 2 additional hours into each athlete's circle. One, two, 1, 2, 1, 2. So each athlete has the same amount of place value discs. Each athlete has 2 ones, 3 tens, and 2 hundreds. So I'm going to write that out as 2 hundreds plus 3 tens, which is 30, plus 2 ones. Now I'm going to compose these values. 200 plus 30 plus 2 is a total of 230. 32 hours. So let's go back to our original problem because we've done a lot of mathematical work. Let's make sure that this makes sense. So we know that 7 athletes spent a total of 1,624 hours cleaning. So we knew we had to take 1,624 and divide it by 7 to find the time that each athlete spent cleaning the locker rooms. So we began with placing the value of 1,624 in our place value chart. And then we wrote down our facts that we knew. And we used this information to help us decompose the different place value discs to find how many would go into each athlete's circle. Because we are finding out how much time did each athlete spend cleaning their locker, we're only going to take a look at just one of the circles. When we did that, we found out that there were 232 hours in each one of the circles. Okay? So when I solved 1,624 divided by 7, I found the answer to be 232 is the time that each athlete spent cleaning the locker. So great fourth grade mathematicians will answer the question, how much time did each athlete spend cleaning the locker room? Each athlete spent 232 hours cleaning the locker rooms. And I'm going to bet, locker rooms. And I'm going to bet that the time that they spent cleaning will make sure that they're not so messy the next time. Hopefully this has been a valuable video for you to watch as we used the place value discs to show division of a number with up to 4-digit dividend and a 1-digit divisor. This can take some time, but it's a great way for students to understand what is truly happening with the equal distribution of all of the values. Have a great day.